Okay, we are move on to the next question. Okay, am I audible? Okay, fine. So we are move on to the next numerical. Okay, so the next numerical is find the slope of the bed of the rectangular channel of width 2 meter when the water depth is 2 meter. When the water depth is 2 meter and the rate of flow is given as 20 meter cube per second. Okay, so rate of flow is nothing but your discharge. Okay, rate of flow is nothing but your discharge. So we need to find out the bed slope. We need to find out the bed slope. We need to find out. Okay, bed slope is we need to find out. Width of the channel is given, that is 2 meter. Depth of flow is also given, that is 2 meter. Discharge is also given, and Sage's constant is given, that is C, 50. Sage's constant is given. Okay, 50, 50. 50 is given. Okay, so these are the given parameters. We need to find out bed slope. Okay, and width of the channel is given, and the channel is rectangular channel. Okay, this is also given. Channel is a rectangular channel. Width of that channel is 2 meter. Depth of flow for that particular channel is 2 meter, and the discharge is 20 meter cube per second. Okay, and Sage's constant is given 50. So as this is a rectangular channel, okay, so we are going to find out area. Area is nothing but width of the channel multiplied by depth of flow. So 2 into 2, 4 meter square is area. Okay. Then we are going to find out the weighted perimeter. Weighted perimeter we have already discussed. For rectangular channel, this is y, this is y, and this is width of the channel. So it will be b plus twice y. Okay. Width of the channel. Sorry, weighted perimeter. B plus twice y. Okay. So here. So width of the channel is 2 meter and y value is 2 meter. So 2 2s are 4 and 5 6. Without weighted perimeter is 6 meter. Okay. Then we are going to find out the hydraulic radius. Okay. Hydraulic radius is nothing but area divided by weighted perimeter. So area we have calculated 4 meter square and weighted perimeter is 6 meter. The unit of R is nothing but your meter. Okay, always remember R is hydraulic radius and unit is meter. This is meter square and 6 meter. 1 meter will be cancelled out. It will be 2 by 3 meter. Okay, that is your hydraulic radius R. So velocity, we know discharge equal to area into velocity. Okay, discharge is nothing but area into velocity. Area multiplied by velocity. So velocity is nothing but area divided, sorry, discharge divided by area. Okay. So see here, discharge is known to us. Oh, it is already given 20 meter cube per second. Okay, area we have already calculated, that is 4 meter square, and we find out the velocity. 4 5 is 20, so 5 meter per second or velocity. Definitely in the question it's given says is constant. So here in this numerical we are going to use Sage's equation. Okay, so Sage's equation is nothing but v equal to c root over r s, that is your bed slope. Okay, so we need to find out this parameter. Okay, so to find out this parameter from this equation we need velocity. So velocity we have already calculated, that is 5 meter per second. We need Sage's constant, this is also already given as 50. Okay, Sage's constant is already given 50. Okay, r is already calculated, so we have one equation, one unknown, so we can easily find out the bed slope from this equation. Okay, so here we have separated out the bed slope, vy divided by c root over r, then we remove that root over, then it will be square. Okay, then it will be square. Okay. So velocity we substitute 5, such is constant is 50, and r is nothing but 2 by 3 whole square. So if you solve the slope, you are going to get is 3 by 200. Or you can also write 3, this 3 by 200, you can also write 3 in 200. Okay, 3 in 200. Okay, very simple. Okay, only you have to first you have to identify what is given and what you need to calculate. Okay, we move on to our next. Okay. So till now we are always discussing about rectangular channel, and we all know that calculation in rectangular channel is much simple than the other channel. So that is why the next problem is related to our trapezoidal channel. Okay, so the next numerical is we need to find out the discharge. Okay, of a trapezoidal channel. Okay, we need to find out discharge of a trapezoidal channel. What is given? The width of the channel is given 8 meter. Okay, side slope is given 1 horizontal is to 3 vertical. Okay, 1 horizontal is to 3 vertical. Depth of flow 2.4 meter. Okay, and bed slope is given 1 in 4000. Sages constant is given 50. Okay, just kindly write it down. Okay, we need to find out discharge of a trapezoidal channel. Width of the channel is given 8 meter. Side slope is given 1 horizontal is to P vertical. P vertical. Okay. Depth of flow is 2.4 meter. Bed slope is given 1 in 4,000, or you can write 1 divided by 4,000. Okay. And at last the Sage's constant is given is 50. See that C is a constant term. So that is why that 50 is unitless. We don't have any unit for Sage's constant. Okay. So then you draw a trapezoidal channel. Okay. And you write it down that the width of the channel is 8 meter. Depth of flow is 2.4 meter. Okay. And side slope is given as 1 horizontal is to 3 vertical. Okay. See, in trapezoidal channel, we have to find out the top width also. Okay. And see, in rectangular channel, our bottom width and top width of the channel is same. Okay. But in trapezoidal channel, our bottom width and top width is not same. Okay. To find out the area, we have a equation that sum of the parallel sides, that is your bottom width and top width. Okay. Sum of the parallel sides divided by 2 multiplied by vertical distance, that is nothing but your depth of flow. Okay. So to find out the area, we have bottom width, but we don't have top width. Okay. Divided by 2 multiplied by your vertical distance. So that depth of flow is also given. So our first aim is to find out the top width. Top width, that means from here to here. Okay. Top width. Okay. So area equation is nothing but half multiplied by top width in addition to your bottom width multiplied by depth of flow. Okay. This is the area equation for your trapezoidal section. Okay. So first we need to find out the top width. When you consider your trapezoidal section, if this zy, no, you can always find this expression in your textbook. Okay. Z1. That means the portion from here to here is determined by zy. Why? Suppose the side slope we consider 1 is to z. Okay. Z. Okay. 1 is to z. And this vertical distance is nothing but your y. This vertical distance. This is your depth of flow. That we all know. Okay. This is your depth of flow. And the slope, suppose you don't have any slope, it's not known, so we consider 1 is to z as a side slope. So if you see, this 1 is nothing but your vertical. Okay. This 1 is nothing but your vertical, and this z is nothing but your horizontal. Okay. Okay. So this 1 is nothing but your vertical. This is a vertical distance, and this z is nothing but your horizontal distance. Okay. So what we need to calculate is this distance. Definitely this distance your horizontal distance. So what is given is one vertical is equal to z horizontal. Okay, from here we can say, okay, for one horizontal, for one vertical, sorry, for one vertical we have z horizontal. Okay, so then if we consider y vertical, as this is your vertical, okay, this is your vertical and this is your y, that is your depth of flow. So y vertical, what will be your horizontal? That is your zy horizontal. Okay, that's all. So zy horizontal. Okay, so this is the reason why they have directly written it's zy. Okay, if you consider this slope is 1 is to z, that is 1 vertical is to z horizontal, then this portion will be your zy. Okay, now in our question, what is given? Okay, in our question it's given one horizontal is to 3 vertical, one horizontal is to 3 vertical. Okay, in our question is given one horizontal is to 3 vertical, sorry, one horizontal 3 vertical. Okay, it's given. So now, so this is your 1 and this is your z. Okay, definitely that z is horizontal and 1 is your vertical. So to find out z, we need to find out for one vertical how much will be the z. Okay, from this equation if you see what is given, that is one horizontal is to 3 vertical, or you can write that one horizontal is equal to 3 vertical. But here if you see, so we are going to doing this reverse way. Okay, if 3 vertical is equal to 1 horizontal, then one vertical will be 1 by 3 horizontal. Okay, okay. So one vertical will be 1 by 3 horizontal. Okay, if 3 vertical is equal to 1 horizontal, so one vertical will be 1 by 3 horizontal. Okay, see here, this is one vertical is equal to z horizontal. So here we can say that z is nothing but, for our given equation, sorry, problem, our z is nothing but your 1 by 3. Z is nothing but your 1 by 3. Okay, say this z. Okay, okay. So to find out this, we need z multiplied by y. So z is 1 by 3. Y value is already given, that is 2.4. So 2.4 divided by 3, you will get zero point 0.8. Okay. So this portion from here to here is nothing but your zero point 0.8 meter. Okay. Understood? See, those things we have already studied in third semester. Okay. We are discussing here just to brush up. Okay. So if you have any doubt, then I can explain again. And if you don't have doubt, then we are going to proceed. Okay. Okay, now we need to find out the top width. Definitely top width will be, for top width, from here to here. Okay, from this distance till here. Okay, so first this portion will come. This is nothing but it will be same like zy. Okay, that is 0.8, because both the side, your side slope is same, so that is why you are going to get the same value in both sides. So whenever you are going to solve this numerical, you have to find out only for one side. Okay, unless and until both your side slope is same. So from here to here, it's, from here to here is zero point 0.8. Then from here to here, this is nothing but your bottom width, that is your 8 meter. Okay, plus, then again your 0 0.8. Okay, this is nothing but your 9.6, 9 point, this is nothing but your 9.6 meter. So here we are going to find out the area now of sum of the parallel sides. One side is 9.6, that is top width. Okay, and one side is 8 meter multiplied by your vertical distance, that is your 2.4, and the area we are going to get is 21.12 meter square. Okay, okay. Okay. So you've calculated the area, then definitely we need to find out r. To find out r, we know we need area by weighted perimeter. So area we have calculated. Now we need to find out the weighted perimeter. Okay. To find out weighted perimeter, so when you are going to find out the weighted perimeter for a trapezoidal channel, you have to consider this side, then the bottom width of the channel, and then again this side. Okay, to find out the weighted perimeter. Okay, so bottom width is known, but this side is not known to us. Okay, this side we know it's is equal to 0 0.8, we have calculated. Okay, this we know 2.4 meter. Okay, and we need to find out this portion. Okay, if you consider this is your a, this b, and c. So abc is a triangle where you know two side, one is your zero point 0.8, one is 2.4. So this is your 90 degree, definitely this is your 90 degree. So you can use Pythagoras theorem to find out this side. Okay, you can use Pythagoras theorem. As you can see, this is your right angle triangle. Okay, this is your right angle triangle. You know this two side, you can use Pythagoras theorem to find out the other side. Okay, okay. So this is what we are using. Okay, we all know this square is equal to sum of the other two side square. Okay, so here root over zero point 0.8 whole square plus 2.4 whole square. Why we have multiplied 2? Because we have two sides, one is here and one is here. Both the sides will be same as our side slope is same. Okay, so we are not going to find out separately. Once we find out once, then we have to do the addition. That is why we have multiplied by 2, and then we add the width of the channel. Okay, by solving this you can find out the weighted perimeter, that is 13.06 meter. Okay, so try to find out the weighted perimeter and see how much you got. Okay, so weighted perimeter you have already calculated. Then see, in the question it's given Sage's constant, so that is why we are using Sage's formula or Sage's equation. Okay, so to find out the velocity, we have used Sage's equation. So C value is already given 50 root over R value. So R will be area by weighted perimeter. Area we have already calculated, and perimeter we have just now we calculated is 13.06. Okay, we substitute here, multiplied by slope is also given 1 by 4000. Okay, the velocity is approximately 1 meter per second. Okay, then area we have already calculated, we multiplied with velocity, we will get our discharge for that given trapezoidal channel. Okay, okay, so I think it's over. So we are going to the next numerical. Okay, next is for triangular channel. Okay, next question is find the normal depth of a triangular channel. That is what we need to find out the depth of flow. Okay, having the slope of 4 into 10 to the power minus 4 slope, that is longitudinal slope, is nothing but your bed slope. Okay, that longitudinal slope is nothing but your bed slope. Okay, so what we need to find out, we need to find out the y, that is your depth of flow. Why we need to find out, question mark. Okay, bed slope is given 4 into 10 to the power minus 4. Side slope is also given 1 is to 1. Okay, and when it carries, that is discharge is given 1 meter cube per second, and we have given Manning's n. Okay, so we need to find out the n value. Okay, So you kindly try to solve. Okay, this slope is given. So depth of flow we need to calculate. Bed slope is given. N is given. So first you use the area equation, half into base into altitude. Okay. So this is similar to your previous case what we have discussed as your 1 is to z. Okay. If you consider the side slope is 1 is to z, 1 is to z, then this will be your zy. Okay. Similarly, if you consider this triangle, this will be your zy. Okay. So if you consider the area equation, half into base into altitude, as this is a triangular section, half into base will be your twice zy multiplied by y. Okay. So 2 will be cancelled out, equal be zy square. Okay. Zy square, y square. Okay. Area will be zy square. Okay. So here it's not visible properly, so that is why zy square. Okay. Area is zy square, and you see our z is equal to 1 in this situation. Okay. In this problem your z is equal to 1. Okay. So we substitute z equal to 1 and we will get area equal to y square, since z is equal to 1 for the given numerical. Okay. Then we try to find out the weighted perimeter. Okay. So if we consider the triangular channel, okay, if this is your level of water, so this side we are going to consider and this side. Okay. So like Pythagoras theorem, you find out one side and you multiply it by 2. You will get a weighted perimeter. Okay. So depth of flow is not known to us. So that is why this is zy. So if you do the Pythagoras theorem and what you are finding out, root over zy whole square plus y square. Okay. And as we are considering this weighted perimeter, we multiply it by 2. Okay. And finally, you will get an expression like this, twice y root over 2. Twice y root over 2. Okay. Then we need to find out the r. R is nothing but area by weighted perimeter. Area, we got the expression y square divided by twice y root over 2. Okay. So this y will be cancelled out. So will be left out y by 2 root 2. Okay. Then we have taken the equation of discharge. Okay. As discharge is given 1 meter cube per second. Area again y square. Okay. See, as it is called normal depth, that's why I have taken y suffix n. You can directly write y also, no issue. Okay. Y square. Again, for calculating velocity, as Manning's equation is given, we have used Manning's equation. Okay. So 1 by n v equal to 1 by n r to the power 2 by 3 s to the power half. Okay. So this will be y square plus 1 by n. In place of r, we can substitute this equation. Okay. Y by twice root 2 to the power 2 by 3. Okay. And slope is already given, longitudinal slope, or you can say bed slope, that is 4 into 10 to the power minus 4. Okay. Then you do the simple calculation, and from here, as we have one equation, you can see in this equation we have one equation and one unknown. Okay. So you can find out the that unknown term. Okay. That is why you try to calculate and see you are getting the same value or not. That is yn equal to 1.13 meter. So you people are getting the value for depth of flow 1.13 meter. So it's not that much difficult, okay? Just you need to understand what you need to calculate and what is given, okay? You always remember for velocity, you use Manning's equation or Sage's equation. It depends on what is given, okay? If Sage's constant is given, then you have to go for Sage's equation, okay? Or if Manning's constant is given or Manning's coefficient is given, then you have to use Manning's equation, okay, for velocity. So you do one thing, you try to solve this, okay, as a practice one, okay. It's similar to your first numerical. It's a trapezoidal channel because the most difficult one is your trapezoidal channel, okay. And when your side slope is given 1:1, then it's very easy. You can directly consider your z value is 1. This z value is 1, okay. Z is equal to 1, okay. Okay. So when your side slope is given 1:1, you always remember your z is equal to 1, okay. So you try to solve this equation, solve this problem. Here also you need to find out the discharge. Here also you need to find out the discharge of a trapezoidal channel, width of the channel is given 10 meter. Width of the channel is given 10 meter. You did not to write the whole numericals, okay. You directly just write the given data, okay. That is your what you need to find out, that is discharge. Discharge is question mark. Then it's given trapezoidal channel. Width of the channel is given 10 meter. Side slope is given 1:1. Depth of flow is given 2 meter. Okay. Depth of flow is given 2 meter. Slope is given. Slope is not visible here. Let me see here. Okay. Okay. Slope is nothing but your 10 to the power minus 4. Okay. Slope is 10 to the power minus 4. Okay. Here. Slope is also given. It's 10 to the power minus 4. Okay. Manning's n is also given. That is 0.02. Okay. So you have to use Manning's equation and you need to find out the discharge. Okay. After calculating discharge, you have to also find out the Sage's coefficient. Okay. That is the second part of your question. Okay. First, you need to find out the discharge, okay, of a trapezoidal channel. The width of the channel is given 10 meter. Side slope is given 1:1. Depth of flow is given 2 meter. And longitudinal slope, or you can say bed slope, is given 10 to the power minus 4. It's not visible. You just write it down, 10 to the power minus 4. And Manning's n is given 0.02. Then you find out the discharge. Then you have to use Sage's equation and you have to calculate Sage's coefficient. Okay. So you try to solve this numerical. Okay. And we will discuss this numerical in the next class, as this meeting is going to end very soon. Okay. So you can draw a trapezoidal section. Okay. So during examination, you draw or not, it depends on you. Okay. If you don't want to draw this trapezoidal section, then it's up to you. Okay. So the first step, we need to find out the top width. Okay. So as I have already told you that if it is 1:1, our Z is equal to 1. Okay. If Z is equal to 1, Y value is given 2 meter. So that is why 2 plus 10 plus 2. Okay. That is your 14. Very simple to calculate. Okay. So here Y is 2 meter multiplied by 1. That is 2 meter. 2 plus 10 meter plus 2 meter. Then you can directly write 14 meter your top width. Your top width is your nothing but your 14 meter. Okay. So whenever you have a side slope of 1:1, it's very simple to calculate top width. Okay. So you can directly calculate and substitute 14 meter, and plus 10 meter is your bottom width, divided by 2 multiplied by vertical distance, that is your again 2 meter. So this 2 will be cancelled out. So area is your 24 meter square. Okay. Okay. So yeah, try to solve this equation. Sorry, try to solve this numerical, and then we will discuss its answer in the next class.